Okay, related rates part 2. So I think I have 3 more examples for you. So a conical paper cup, 3 inches across the top and 4 inches deep, is full of water. The cup springs a leak at the bottom and loses water at a constant rate of 2 cubic inches per minute. How fast is the water level dropping? At the instant the water is 3 inches deep. How fast is the radius of the cup changing when the water level is 2 inches? So this is a twofer. I first see that I have the dimensions of the cup, so 3 inches and 4 inches in depth. So it looks something like the radius at the top is 3 inches and the depth is 4 inches. And the cup springs a leak, it loses water at a constant rate of 2 cubic inches per, so we're going to lose 2 inches cubed per minute. And since we're losing 2 inches, it's going to be a negative. It's minusing the water from the cup. And so what is that a change of when we take out 2 inches cubed per minute? That is the rate of the volume over time. All right. So how fast is the water level changing at the instant the water depth is 3? So how fast is the water level dropping? How fast tells me it's a rate. So I know all of this, basically. And I want to know the water level. So water level would be the depth. So the dd. Oh, I made it height. So dh dt. I'm going to call that height of the cup. And dh dt, when r is equal to fast in the water is 3 inches deep. When h is equal to 3 inches. All right, check it out. First off, I see that the 3 is misleading because the radius at the top of the cup is equal to 1.5 inches. It's half of 3. So be careful. That says inches under there. Move my little face. Okay, 1.5 inches. So is there anything that will compare the radius and the volume of a cone? And guess what? There is. We wrote it down in yesterday's notes. So volume is equal to 1/3 pi r squared times h. And I can see a whole bunch of variables here: volume, radius, and height. So I kind of want to get rid of one of them. And I can because I know that the shape on the top of the cone right here, right there, that is a right triangle. So I'm going to take this right triangle. We're going to call it the radius versus the height. And then I have a proportional triangle of 1.5 to 4. So as the height drops, the radius will drop with it proportionally. Okay, so I can set this up as a proportion. R over H is equal to 1.5 over 4. Cross multiply, I get 4R is equal to, actually, let's just multiply by H. That seems like a lot easier. So I get R is equal to 1.5 over 4H. And I'm going to multiply this by 2 so that I no longer have a decimal, giving me 3 over 8 times H. Okay, so we're going to use this right now to help us out, because ultimately what I want to know is actually, let's set this up. So I have D, Okay, I have the volume is equal to 1/3 pi r squared times h. And what I'm going to want to know is what dh dt is. So if I get rid of r and write my equation in terms of h, that'll be just one less derivative that I have to take. So I'm going to write the volume is equal to 1/3 pi times, instead of r, I'm going to write my 3/8 h and all of that squared times h. Simplify. 1/3 pi times 9/64, and then h squared times h will give me h cubed. All right, keep going here. Volume is equal to, I could simplify, but I think I'm just going to leave it like that because that just seems easier. Okay, so I want to take no, just kidding. Okay, let's take out the 3. I get the volume is equal to, well, my computer's way behind. Okay, the volume is equal to 3 pi, 3 pi over 64 h cubed. Look how nice that is. Now we can take the derivative. All right, the derivative of v is dv dt. The derivative of h cubed is 3 pi over 64 is the constant, times 3h squared, times dh dt. And if we look back, I remember that I'm looking for dh dt when the height is 3. So I can go ahead, and I also know dv dt is -2. So I'm going to plug in -2 is equal to 3 pi over 64 times 3 times the height is 3 squared times dh dt. All right, when I solve, I get -2 is equal to, let's see, 3 times 3 times 3 times 3 is 81 pi over 64 times dh over dt. So I get dh dt is equal to -2 times 64 over 81 pi, which is equal to, let's get ourselves a calculator. 2 times 64 over 81 over pi. It is -0.5030. So when I truncate and when I round, I just get 0.503. And then we need some units. Since we're talking about the change in height with respect to time, it's going to be inches per second, per minute. All right, and that is part 1. The second part is, how fast is the radius of the cup changing when the water level is 2 inches? So how fast tells me, I better move my face again. Okay, so how fast tells me that that is a rate. So we get we want dr, the changing radius, when the water level, so when the depth or the height is equal to 2. Okay. So the next part we're going to do is when the height is equal to 2. All right. Okay, since we're solving for dr dt, we need to make sure that we have r in our equation. So I'm going to do the volume is equal to 1/3 pi r squared times h, and this time I'm going to replace h. So 1/3 pi r squared times, I'm going to go back and remember that r is equal to 3h over 8. So to solve for h, I'm just going to multiply by 8 over 3r. Okay, so I'm going to go back over here. 8 over 3r is equal to h. And so then I simplify this to give me 8 over 9 pi r cubed. Okay, and we did that because we want the derivative of r. So we get dv dt is equal to 8 over 9 pi times 3r squared dr dt. Yeah, because that's what we're going to solve for at the end. Okay, now I know that my height is equal to 2, but I got a little issue because I have radius. So how do I solve for the radius? Remember our ratio here. We had like 4 is the height and the radius is 1.5. Now if the height is 2, what is the radius? We can always use a proportion. So 2, the radius over the height, right, is equal to 1.5 over 4. And then we'll just replace my known height with a 2. We solve, we get r is equal to 3 over 4, or 0.75, which makes sense. It's half of 1.5, 3 over 4. So now I can substitute in -2 for dv dt because we're losing water at a rate of -2. 8 over 9 pi times 3 over 4 squared dr dt. Okay, and then we can simplify. I know there's things to simplify, but I'm just going to write this out. 3 times 9 over 16 dr dt. You see the 9's cancel. Those cancel. I get -2 is equal to 3 pi over 2 times dr dt. And so I can isolate dr dt to give me -2 times the reciprocal, 2 over 3 pi, -2 times 2 over 3 pi gives me, wait a second, I got something different. I forgot something big. I forgot a 3 here. No, I got that 3, 9. Nope, that's right. Okay. So I got 4 over. Okay, so I get 0.424. And then our units are inches per minute. And it's negative. So the radius is shrinking at a rate of 0.424 inches per minute. Okay. A 6-foot man walks at a rate of 3 feet per second towards a street light with a bulb 20 feet above the ground. When he is 8 feet from the base of the light, at what rate is his shadow moving? And at the same point, what rate is the length of his shadow changing? So again, 2 questions in one, my fave. Okay, we're going to set up, I think we're playing, yeah. Okay, we're going to set up our situation. So I have 20 feet for the street light, and our guy is 6 feet, and then I have what's going to happen is the light is going to beam down, it's going to hit his head and create a shadow right here. So the total length is the shadow. He is 8 feet from the street light. okay? But that changes depending on if he's walking. So right now he's walking towards the street light, so that 8 feet is going to change, so we need to give it a variable. I'm going to give it the variable x, okay? And the shadow is going to be s. I'm going to give this extra length the variable L. Okay, so right now I know that our guy is moving at a rate of -3 feet per second, and he is moving towards the street light. So the length since he's walking towards the street light, the distance of 8 feet is going to shrink. So we're going to use a negative rate. We want ds dt when x is equal to 8 feet. So we'll go back and revisit that. So when he is 8 feet from the base, what is the rate of the tip of the shadow is moving? So we want to know the rate of the shadow, okay? All right, so here we go. I have X's and S's and all kinds of things. So I can tell from my triangle that I set up that this is another proportion. I have 20. The two heights related to each other are also the ratio of S, the two lengths. So the total of S, the big triangle, over the length of the small triangle, L, which is S, the whole thing, minus X. Okay, I am going to simplify this. 20 times S minus X is equal to 6S. To subtract 6S, giving me 14S. Wow, I don't know what's going on with my computer. Is equal to 20x. Okay, then let's just get s by itself, giving us 20x over 14. Now we can take the derivative. So ds dt is equal to 20 over 14. The derivative of x is 1 times dx dt. All right, so ds, that's what I'm trying to find, is equal to 20 over 14 times -3. So ds dt, the length of the shadow, is going to equal -60 over 14, which is equal to -4.615 feet per second. Okay, second part of the equation is, what is the point? I have no idea what's going on with my computer. Okay. What is the length of the shadow at the same point? What rate is the length of the shadow changing? So in this case, we want to know just the length of the shadow. Just the length of the shadow. Okay. So I'm going to set this up as the length is equal to S minus X, because I want to use all of those variables. So I want to know dl dt, the length. Okay, so this is a really simple equation. The derivative of L is dl dt. This is a simple equation, but a hard one to come up with on your own. Okay, I know dl dt. Oh no, I want dl dt. I know the rate that the shadow is changing is -30 over 7, which I got from right here. -30 over 7 minus 3. And I plug that into my calculator to get that this is about equal to -7.285 feet per second, or negative 7.286 feet per second. So this is rounded and this is truncated. Okay. Okay, changing angles. So this time the airplane is going to fly at an altitude of 5 miles. So it's going to stay at the height of 5 miles towards the point, like going over the observer. And the airplane is going at a speed of 600 miles per hour. We're going to find the rate at which the angle of elevation is changing when the angle is 30 degrees. The angle of elevation is this theta right here. Okay, angle of elevation, theta. Ooh. All right, so we're finding the rate of theta when theta is equal to 30 degrees. We want d theta dt when theta is equal to 30 degrees. We know that the plane is 5 miles above us. We also know, I'm going to call this length x. We also know that the plane is moving at a rate of negative 600 miles per second. So, and because it's moving horizontally, we're going to call that dx dt is equal to negative 600 miles per second. All right, so we need to have a theta, an x. What could we use? I think we should use some trig. I know that this equation tangent theta is equal to the y length over the x length. And that's nice because it has thetas, it has x's, it has y's, okay? So next up, I know we aren't often able to do this, but the y length is 5. Does it ever change? Does the height of the airplane ever change? No. So we can actually plug in 5 here, okay? So 5 over x. I have the tangent theta is equal to 5x to the negative 1. And then let's go ahead and take the derivative. Tangent is secant squared times d theta dt is equal to, let's see, negative 5x to the negative 2 dx dt. Okay. Next up is to start substituting. Also, I know secant is 1 over cosine squared theta, so I like cosines better, so I'm going to use that. Okay, here we go. I know that I want to evaluate when theta is equal to 30. So I have 1 over the cosine squared of 30 degrees times d theta dt is equal to negative 5 over, I'm going to actually write this fraction as 5 over x squared. That just seems easier. Okay. And I am like, wait a second, I think I'm going to need something for x squared because I have too many variables here. And I know that dx dt is equal to negative 600 miles per second. So let's see, how can I figure out what x is? Well, remember trig? I have a right triangle. I have a 5 for my y. My 30 degrees is my angle. So the hypotenuse, since this is a 30, 60, 90 triangle, 10 is going to be the length of my hypotenuse, and 5 root 3 will be the length of the horizontal line. Okay, so I can substitute in 5 square root 3 squared for x. And now it's just a bunch of solving. So d theta, which I did wrong a bunch of times before this, negative 5 times negative 600 times the cosine of 30 degrees all over 5 square root 3 and all of that squared. Okay, cosine 30 is, if you look, cosine 30 would be this guy over this guy, which is root 3 over 2. So d theta dt is equal to negative 5 times negative 600 times, well, let's put this over, 25. This, root 3 squared is 3, okay, times root 3, ooh, I forgot a squared, over 2 squared. Whew, I made it. Okay, I am honestly just going to type this into my calculator, and what I get is 30 degrees per hour. So the angle as I move this way at negative 600 miles per hour, the angle is changing at 30 degrees per hour. So that makes sense because if I'm moving to the left, then I'm going to have to keep looking higher and higher and higher to see the airplane. So the angle is increasing. And that is it.